Few companies embody speed and agility, the theme of the Information Week conference, quite like FedEx. And we're very pleased to have back at the Information Week 500 conference the Executive VP and CIO of FedEx, Rob Carter, one of the sharpest execs in the business today. Rob's here today to talk about what he calls dominant design. It's essentially an infrastructure and application architecture. It's also FedEx's version of the private cloud that we've all heard so much about. Sometimes it's a little nebulous, and Rob today will talk in very specific terms about what the private cloud means to FedEx. Rob thinks dominant design and the technology advancements and trends that underlie dominant design are among the most important and game-changing trends of his 30-plus year IT career. So it's important stuff. The way we're going to break this up today, Rob has a 15, 20-minute presentation. We'll go over the ins and outs of what he means by dominant design, what it's doing for FedEx. We'll turn things over to our esteemed commentary desk after a little Q&A between Rob and myself. Just as a reminder, Ken Kushar at EJ Gallo, Seth Raven of Rimini Street, Art Whitman of Information Week. They'll be weighing in on what Rob has to say. Then we'll turn things over to the audience for some questions. So, ladies and gentlemen, Rob Carter.
Thanks. I'm just going to sit here with Rob and make this kind of a casual presentation as I get started with the dominant design constructs. You know, this isn't a particularly FedEx talk at its beginning. As we get into the questions and afterwards, we'll talk more about specifically our implementation of this. But I do think there's a really important set of trends that are taking place in the industry today. And I want to highlight those to you with this conversation around dominant design. So you probably can't see exactly what this is as I popped it up there right now, but it's a chart that I found that's Guide to International Plugs and Sockets. And so what if you were coming here to California and you had to whip one of these babies out and see what the Orange County adapter was with regard to how to plug in when you got here? And the point that this chart makes is that there are some really important standardizations and commonizations that occur over time. And as you go through time and you're in the midst of it, you know, it doesn't look like, aha, there's the dominant design point and here's my opportunity to jump off and standardize around this. It looks like chaos and clutter and all different kinds of formats vying for position out there. And I would argue that in our industry, in information technology, we've been watching that chaos for the last several decades. Information technology, and especially enterprise computing, is not a particularly old science or art or craft, whatever you want to call it. In fact, up until about the mid-70s, information technology was kind of payroll, accounting, and some scientific stuff. Only in the era of the 70s forward, so about 30 to 35 years, have we had enterprises that really were attempting at that point to drive their entire business on the basis of technology and with technology in flight. And we've been through a tremendous amount of chaos in that period of time. Here are some other examples throughout the last 130, 40 years where a dominant design point emerged, and what you see is some incredible mortality in the firms that support, you know, whether it's typewriters or automobiles. You see in the early part of the 20th century, there were, you know, almost 80 automobile manufacturers, and, you know, once kind of the core internal combustion drivetrain technologies that have propelled us forward came into play, you know, that's when a lot of the competitors fell out, and that's when it started looking like a lot more core technology was going to drive automobiles or televisions or transistors and tubes forward. Ray Lane mentioned this morning, but Thomas Watson Jr. was in the midst of one part of this chaos, and there were 7 other players out there, and so Thomas Watson Jr. was forcing an incredible change in the IBM company with the System 360 architecture. When he pushed that, he was fighting everybody in his company and in the industry, but he was saying, until we get to some core platforms, architectures, and technologies, we'll be just another one of these companies. And of course, all of those are, at least in the computing world, significantly smaller or gone altogether. But the horsemen, as I call it, the 4 horsemen of dominant design really cover the landscape of server, network, storage, and software technology. Some really key technology inflection points occurring in virtually all of these spaces, and that's what I'm going to dive into now. So let's start with server technology. When you were a kid, this is a story about the power of 2 to the n. And so we know that Moore's Law has said that technology is going to double approximately every 2 years. That time frame's changed a little bit, but we're in this 2 to the n phenomenon when it comes to microprocessor technology, and particularly the 8088 string of processors. But when you were a kid, did anyone ever ask you the question, which would you rather have, a month in which I give you a penny on day 1, 2 cents on day 2, 4 cents on day 3, up through day 30, or would you rather have $1 million? And so as a kid, you almost always get that question wrong, right? You say, I want the $1 million. Kurzweil talks about, this in his book as the grains of rice and, and the bet with the emperor. But it's all about 2 to the n. Well, let's take a look at how this riddle solves itself. And what does 2 to the n look like over the course of 30 days? So it winds up being right at about $5 million is what that penny becomes when you drive through those changes. But where are we with regard to 2 to the n and Moore's Law? Here we sit at about generation 19 in the Quad i7. So we're about 19 doublings into this phenomenon. And we sit there and we go, wow, the horsepower and the incredible potential of these servers as we harness them together is just extraordinary. Who could have imagined that we had horsepower that looked like what we've got today? But let's put it in context to where we're going. Here's 2 to the n for 23. I picked 23 because it's about maybe 8 years from now. And so we're still at the pretty flat part of the curve when it comes to the month. And, if you looked at where we are today compared to what 19 looks like in the riddle that we talked about, 19 is about $5,000 in the penny riddle. So from 5,000 all the way out to 5 million here by the end of the month. And the month isn't that far away from us. We are getting ready to get into some extraordinary doubling potential inside these environments and how they work. It's just an amazing set of technologies that are changing our view of what the server infrastructure looks like. So most of our data centers look like the one on the left. We have different colored boxes, different height, different platforms running on those. There's all kinds of things that differentiate and delineate that hodgepodge of technology that's out there in many of our data centers. But the looking ahead look in the server world looks like this enterprise capability on the right. And oh, by the way, this is what everyone is deploying, whether you're talking about public cloud providers or private, or in fact, that's what's enabling hybrid, the ability to live across these gaps between scale-out x86 architecture, which allows you to take servers and harness them and cluster them and virtualize them and utilize that as general purpose compute resource. highly purposable technology, getting ready to go through extraordinary levels of performance and power, footprint, power consumption, and just overall capacity. That environment is at a very big inflection point right now with what's happening out there in the cloud. So we'll call the server horseman scale-out x86 architecture. And whether you look at Facebook or Google or Amazon or Force or FedEx, all of, and probably many of your data centers as well, it all looks like scale-out x86 for the most part for the future. The next horseman is network and what's going on in the network space. So these are all these core infrastructure things that we all count on to run our businesses and connect to our customers and suppliers. But this one's really interesting too. I've been at this 30 years and I actually remembered most of these network protocols, just a bizarre number of them that we've dealt with through the course of our careers and implementations. And yet there's a dominant design component emerging in this as well, and I'm sure you know what it is. It's kind of hiding right there in the middle, but it comes out and says, well, regardless of those proprietary layers of network and network infrastructure, we're to a point now where TCP is the dominant technology and the dominant infrastructure in the network space. And it's complete lingua franca for all of the computing environments, from the mobility in our pockets all the way up to the core data center constructs. And when you look at the speed and capacity of these networks, these core wired networks and what's going on there, all the way up to the dense wave division multiplexing optical networks that are occurring, there's no end in sight in the capacity that we'll be able to run over these networks and how it makes the world look. The world is this highly connected set of network endpoints now. But there's one piece that's missing from that if all you do is look at these core pipes and how they work. And here's what's missing from that. So if we look here at the Monarch Beach Resort, the St. Regis, there's this pervasive thing that fills in all the gaps. It wasn't that many years ago, Rob, when we came to these conferences where we had to have a jack to plug into, or we had to, use, some kind of dial-out capability. But all around us right now is this pervasive wireless capability that provides that last eyedropper of connection so that the jacks are out there still, but now they're hooked to wireless routers and core wide area wireless networks that allow us to be constantly connected. Very powerful notion of pervasive internet protocol and the pervasiveness of our ability to access this core network technology that's out there. The next horseman is storage, and what's going on in the storage world is equally as compelling and interesting. We've lived through a lot of different technologies when it comes to core storage and the way that it works, but we're moving into this era of no moving parts in our storage. The solid state storage and SD technologies and flash memory are really changing everything now. And when you look at them and you look at the comparison, in 1956, this was a 5 megabyte hard disk that IBM was loading into a plane with great fanfare. Big spinning magnetic drums and lots of moving parts, and you compare that to a 64 gig micro SD, and again, no end in sight. And these SD cards now, regardless of whether you find them in the tip of your fingers or often dense storage arrays, provide such amazing capacity with no moving parts, very rapid access into a solid state array. And we've had a 17 million fold increase in the density of information's ability to be stored, again with the physics not showing any limitations, no end in sight in our ability to provide density of storage. So through that, you can see both localized density and array density off in the cloud. And so whether you're looking at these new network attached storage boxes that have massive amounts of SD in them, or whether you're holding 32 gigabytes in your back pocket in your iPhone, we have what I would propose as intelligent storage, the ability to forward cache, and personalize key information that we need. And the Google Docs story, is an example of that. We need the ability to persist that stuff close to us, but we really love the idea of having it off in the cloud where it's pervasively available through the networks. And then the last component here is software, and how software is changing. Some pretty important things going on. And this is kind of an Information Week story, because a lot of Information Week veterans like myself or customers remember Scott Dinsdale. And Scott his last job in our part of the industry was working for Sony BMG. And he was elected to be the head of the Digital Rights Management Consortium to solve this problem. It was this insane problem of all of the various interests in music and how that would work. And many of us know that Scott quit after a couple of years because his head hurt so bad, and moved to Jamaica and started a rum company where he was, kind of a pirate rum runner, which really suited his personality pretty well. But then, it's because the problem looked unsolvable. Radiohead and Metallica had completely different set of needs than the consumer or the record label or the producer, and nobody was winning in that mess until something interesting happened. A service emerged, kind of out of that chaos, and it wasn't an application rationalization initiative where we said, well, we've got to get all of these, folks to eliminate their applications. It was just a better service that showed up at the end of the day, and we'll call it a tune for 99 cents. And so instead of an application rationalization initiative, people just started to point to it, and they started to feel good about it because, it rewarded the artist, it rewarded the labels, and it was good karma, and it was good business, and it was safe. You didn't catch a virus from it. And so everybody started getting along pretty well around a core service offering that was out there that is essentially service-oriented architectures, and how small-grained and coarse-grained services become important to us. But at the end of the day, this whole environment is about these sets of connections that are happening where services are coming online. Infrastructure services, platform services, software services, all driving incredible capability and capacity by the variety of things that you can tap into. The cloud infrastructure is essentially a tap-into infrastructure that allows you to get to the stuff that you need, regardless of whether it's inside your firewall or inside or out in the wild. So that is essentially what we believe to be the four horsemen, and how they come together at this key inflection point to drive what we feel like is a core cloud computing inflection point that says general purpose computing, high density networks, high performance server farms, and incredible capabilities in storage and software are changing everything about what it means to deploy technology these days.
So FedEx built practically speaking, FedEx built a new data center in Colorado Springs, which embodies dominant design. Can you describe a little bit what the makeup of that data center is and how it's different from the traditional FedEx data center?
So sure, one of the things about it is I'll start with this because it's one of the coolest things about it. It's a LEED Gold certified data center. It uses incredibly less power, less footprint than our typical environments. And a lot of that has to do not with just the fact that it's in Colorado, but its efficiency. So the data center itself and the way that the performance units are accessible by the applications, no longer do we have lots of different stacks and heights of boxes of various colors. It looks like rows and rows of core scale-out x86 infrastructure. We didn't just pick up our applications and move them into a virtualized environment. We ran them through a set of reference architectures. So we commonized the data layer, we commonized the messaging layer, we commonized the port access for all those applications, and moved them through what we call the enterprise data center minimums, or the reference architecture. So we spent time and money pushing the applications to behave much more commonly and standardly on that array. If you go around to the back of those boxes, all you see going into the back of them is one fiber optic cable that's 10 gig Ethernet. So it's IP. There are no more host bus adapters. There are no more NIC cards. There are no more any of those things. There's one way in and out of the box. Of course, there's a power supply that drives power to it. But that scale and commonality creates very few single points of failure. And so if you went into our legacy data center and pulled up one of the floor tiles, it's just enough to give you a heart attack. You look down at this mass of cables. If you go into the new enterprise data center, we don't have any cables under the floor. We have a little thin trough that runs up, above the servers with just a small bundle of fiber optic blue wires, blue cables that run to the back of each server. And it's so clean, it's so capable. And then there's a lot of network attached storage on the back side of that. So we're using NAS technologies to access high performance storage arrays, and while some of it still spins, I really do predict that we're on the verge of having very little spinning medium out there anymore, because even when you look at the input components for SD storage and solid state storage, you don't wind up with a need to have things that spin real fast and have mechanical heads that go in and out, even if they're late. Just think of the cost of designing and building and delivering that compared to a little SD card and what it's capable of doing.
So you touched on the redundancy ability that gives you. What are some of the other benefits in terms of, let's talk cost, let's talk, the theme of our conference is speed and agility. Does these commonized applications allow you to spin up new apps faster than you could before? If you could just talk about some of the business benefits.
Well, let's talk about cost first, because cost is so compelling. I mean, I have an example out there that I've shared with the business that's really compelling. We had a big relational database environment in our revenue processing world, our billing world, and over the years we had put millions of dollars of hardware to work inside, just to support that database environment for billing. Well, in the new data center, it runs on what we call our hosted data services, or HDS, a very small number of industry standard servers. And so what we had, from a capital asset standpoint, spent more than $10 million on over the last few years. Just the hardware alone cost about $30,000 in the new environment to implement. So significant cost savings by deploying industry standard servers with, and we use, Linux, Red Hat Linux, and core Oracle for at least our database environments. But then, a lot of the speed and agility as we move these applications into the reference architecture, a lot of it comes from, as you work your way up the stack, common authentication services, common logging services, common data services like we just described, common message bus infrastructure. So we're not writing custom application interfaces. We're writing to the bus, using the bus to deliver messages. We actually have several billion messages a day today on our core messaging bus that delivers, not just tracking information, but everything about the business through that. So the agility and some of the speed and performance comes from application developers using, the core stack, not just at the infrastructure layer, but at the platform and reference architecture layer, and then using error handling and log handling and authentication. All those things I mentioned, are becoming totally common between applications now, as opposed to having to rewrite them. And in the access layer is one of the most important parts of that, how we provide both customer access to these applications and internal access to the applications, not having to rewrite, all these login infrastructures and security infrastructures over and over again is really powerful.
And do you plan on moving the dominant design architecture to, how many data centers does FedEx have? And will you eventually move everything to that?
We will eventually move, and almost by the definition of at least what I believe dominant design means is, I think that's what data centers are going to look like. And so we started with one brand new one, but now we're going through that topology refit for our existing data centers, and we're working on the big Memphis data center now.
Okay.
But one of the cool things about cloud technology is the resiliency that it provides you for multi-site applications. We use tools like Golden Gate that allow us to replicate across these data centers. And so when we look at Amazon or Force or any of the kind of core cloud providers out there as far as infrastructure providers are concerned, we look and we see an infrastructure that looks exactly like ours. So it's easily imaginable to us that at least in the event of disaster resiliency that we've got access, unlike the arrays that we've had in the past, which were completely unique. Where do you get, it's not like the old ComDisco days where you've just got a few mainframes and you go, rent some time, with them. You had all of this technology and it was very hard to find a mirror of that somewhere that, in a smoke and rubble event that you could imagine actually effectively starting that environment up. Today, though, we believe that, there are a number of providers that will be able to support us should we have, significant events like that.
So this is fundamentally infrastructure, and when discussions of infrastructure sort of go to the executive board level, they can get a little dense. How did you go about sort of making the business case for moving the data centers to this new architecture?
Well, I'm a big believer in ugly pictures that reflect your current reality. So I had a lot of ugly stuff out there that, that I could show to the board or show to the management that was just frightening. Whether it was that picture of, of the back of those servers and the floor tile pulled up, or, we did this incredible application map that showed all of our applications across the enterprise. And it was so intense and so complicated, Fred Smith started calling it, not so affectionately, Hurricane Rob. And it looked like Katrina. When you showed this picture, it literally looked like this hurricane getting ready to wash over the shore. And so it was I had a lot of ugly pictures, and then particularly talking about how the data center could be built, what the core network capabilities like if you did take the applications through the reference architecture and modernization. And then with a service-oriented architecture is a really important part of this for us in what we call the platinum core. So we have, I speak to the business in terms of this picture that we have, and I wish I had it with me because it'd make more sense, but the purple core in the FedEx brand, the common color across all of our companies is purple. And so the purple core is what we do on all of our customer-facing applications. So we came up with a plan to deliver all of our customer-facing applications in a unified way. The platinum core is in the center, and that's this infrastructure that we've been talking about, but it's also a set of core foundational services. And so when you decompose our business, a customer is a customer, and an address is an address, and a label is a label, and a route is a route, and a rate is a rate, and yet we had applications that use that stuff much like what Dinsdale was faced with in the music industry. It's just chaos with how many of them had grown over time. And so the ability to drive that down to some foundational services that supported the business, I'll call it in a tune for 99-cent format with service orientation, so that you know who a customer is, you know what a label looks like, and you don't rewrite software over and over again in order to deliver those things.
Now, did you make bets on different vendors as a result of this transition, or is it essentially the same kinds of vendors providing the core of your data center than were before?
Listening to Ray this morning, we did make bets. We didn't want to spend a lot of time because we do believe that, at both at all of the server, storage, and network layers, that these are core and common technologies. But we went with a provider that could help us build it out, help us, make sure that it ran solidly and effectively. So we made bets. We didn't just kind of randomly put, varieties of industry standard servers in the data center, but I have it's not a unique problem, but it's one of the more challenging problems in my job is that every one of those companies is our customer, and most of them are really big customers, and most of them are really demanding that I buy some of their stuff and not just all the other guys' stuff because they tend to hate each other.
So we've talked about the private cloud. Is there any potential for some workloads to move out of your data centers and move toward public cloud services? And maybe give us
Sure.
a peek at what might be possible.
So Salesforce is a good example of that. I had a pretty big team. We have about 7,000 sales professionals around the globe. Our sales force is global and intense, and has a lot of requirements to it. But we use our customer data and our core view of the customer. And then we live in a hybrid cloud world with Salesforce out of one of their newest data centers, which looks exactly like our data center. So we have a shared application environment where the data and a lot of the core reporting and a lot of the environment in our CRM world is ours, but the core Salesforce applications, how you access them, how you utilize them from your mobile device, and the core framework for Salesforce automation, comes from them in their part of the cloud. And so, to me, that was a really good example. It saved me a lot of time and money. I got to market much faster. And, that's a context. As important as the Salesforce is to us, I would never tell you that they're not strategic. They are strategic. But the Salesforce applications are just context. I don't need to write those things. I mean, it's how do you access customer data? How do you manage territories? How do you drive? And that's what Salesforce does
Right.
well. So I don't need to do that any more than I need to, do HR and payroll.
Any interest in infrastructure as a service? Is that
Well, right now, predominantly as a resiliency and business continuity platform. I mean, one of the great reliefs that I have is we have more of these data centers online. Obviously, we'll be able to support ourselves, but our business is also a little unique in the peaking factor that it has. So as we approach the holidays, we tend to more than double, our transaction rates and our package volumes and things like that. So we have this incredibly peaky business, and it's not always effective for us to believe that we should provide, we have up to this point, we've provided all of that computing resource, and we plan our whole IT infrastructure around peak capacity and, and how we need to be able to support the business when we get into these intense December weeks that are just, dim the lights, kind of mind-numbing volumes that move through there. But I can certainly envision a future where we don't build that capacity, that much flex into the environments, where we have, again, a tap into philosophy that allows us to tap into resources that look just like ours. And if you look at the AWS facility and the amount of network capacity and their ability to, do Netflix streaming and all the things that they do out of that, it's an intense amount of capacity that they have out there that would be quite suitable, with the right security, it'd be quite suitable to a great deal of our workload.
Why don't we hand things over to our esteemed commentary desk. Art Whitman, you're an old data center guy. What do you make of all this?
It's some pretty impressive stuff. I think the thing that strikes me the most is the biggest impediment to adopting an architecture like this can really be having the strength of leadership to actually get your own IT team to believe in what you're doing and to actually follow through on the architecture and make sure that they're actually implementing the plan that you have in mind. And Ken, I know you've had a lot of experience with this sort of thing yourself and a long time friend of Rob's. What do you think?
Well, I have my own four horsemen for you, Rob, and they're about you, actually. A lot of commentary is supposed to be critical and it's supposed to be questioning. This is going to be high praise, so get ready. So, one, Rob, you've always been an early mover. Two, everything you've done has always been a part of your business. It's always had a business context to it. Number three, you've been unselfish to all of us in your advice. Clear, concise, but mostly unselfish. And last of all, the stuff that you do really allows us to follow you closely without having the size or investment, because we can look at what you do and it works. Thank you, sir.
And you're letting me off way too easy. Kenta.
I guess
Thank-
I mean, that I put out that question. So and I'll put it to Rob as well. Is dominant design only for sort of Fortune 500 enterprises, or is this is going to be the data center architecture for just about everyone?
Yeah, I think I think this is leading the way for many people on the mainstream, and I think when we take a look at it, and as you were really talking about, this is a big push with virtualization, the commoditization of the hardware components. I think what's interesting is last year we were talking a lot about clouds and public clouds and security, and you can see that we've moved forward. We've seen a lot more move towards the cloud. Interesting, I find, Rob, with your situation, that you're still not fully comfortable putting it out there to a vendor. You're still building your own data centers. You're still keeping it within your walls for the most part. And I think, again, that's just another step, but it'll be interesting to see how that investment changes over time and how much of your data center you're actually going to own in 3 to 5 years, given the kinds of changes that we're having.
It's a great question. I mean, I'm a big believer in hybrid for the near term. I think that at least large enterprises have enough stake in watching all this formative technology and access to it in a secure and robust and resilient fashion take shape. But 3 to 5 years down the road, it's much like what Sir Ken was saying. I mean, we couldn't have imagined where we are today. The whole internet phenomenon is really only about 5,000 days old, and so 5,000 days ago, we weren't thinking anything like this. We were thinking proprietary, and we were in the midst of that chaos that mapped a lot of those things. Today, in the core dominant design kind of thinking, we've seen a lot of that stuff settle, and what looked like competition to us was really just the energy that gets applied in these new and transformative spaces to settle on dominant design. And we'll begin to see more mortality and more consolidation too. A lot of what we've been talking about is, this incredible buying spree that these companies are on is just more of the settling into, the core providers.
Rob, you made a comment early in about if the security were correct. Could you give us some commentary on that?
So interestingly, I've known, I'll use Salesforce as an example, and he'd probably be proud to hear me say this, but I've known Mark Benioff for a long time. We were both, out in Silicon Valley doing some venture work back in the day, and one of our directors had been a long-time family friend of the Benioffs, and so I was on the board of a company called Jamcracker, which was trying to provide, broad-based, tap into services for back office systems, and Mark was starting up Salesforce. And so for a decade, he was chasing us, trying to get us to commit. And it wasn't anything other than, that they had to prove the security, they had to prove the capabilities that they had were robust, resilient, and and pass muster in our information security world, especially since we're dealing with customer data. And it wasn't until they convinced us of that, both through our audits, certifications, white hat hacks, and various things that I finally talked to him and said, "You're there. We think you're there. We're ready to go." And so it saved us a lot of money and time. And I think companies like that take that very seriously are starting to do a really good job. But once again, I believe it's because the technologies are well understood.
How big was your training effort for your legal staff?
We have all kinds of opportunities there. Just like any big company, it's a big deal. But the conversation we should have around that is in the social spaces and their understanding and buy-in to to social. But we have people out there on the tweet deck these days. We have blog writers. We have Facebook applications and fans. But that was actually the hardest of the journeys, was convincing that this is happening out there anyways. You can either choose to participate in it and influence it in a positive way, or you can bury your head in the sand. That was a completely off topic, but that was the more fun journey.
Why don't we open things up to the audience? It's a little tough for me to see, but any audience questions? Is there mic runner, at least on the left side over here? Yes, right here.
Rob, Charlie Babcock with Information Week. Can you tell us how heavily virtualized your environment is? And did you adopt any kind of internal standard like OpenStack or Eucalyptus Systems to build your private cloud?
Yeah, we did use basically the LAMP stack and Spring for the development of the core services and common open capabilities for a lot of the infrastructure support. It's for some reason you asked a two-part question and I completely zoned on what the first part of that question was. You can shout it out and all. Oh yeah. No, it was mostly open and core technologies. Now we have a lot of management service. Oh, you asked how virtualized we were. That was what it was. I just thought of that. We're about 70% utilization in the new data center. So we went a long ways towards really making these machines work. And that was part of how we got the LEED certification as well, is that we don't have as many machines. They're much more compressed, and we run them hard as opposed to running a whole lot of machines at a very low utilization rate.
We have any other questions?
Another one up front here.
Okay.
You said your data center, or you said that Salesforce's data center looked like your data center. Did you have common inspiration? Did you share notes? Did you cleave to some of the same standards?
We didn't spend a lot of time with them comparing back and forth, but it was becoming really intuitively obvious to us how we could build these, core pod architectures with scale-out x86. And we'd been looking at Facebook and Google and Twitter and a lot of the things that were emerging in the application spaces. And even though those are all very proprietary in the way they build both their servers and their kind of core operating systems around that, it just became obvious that that these technologies were the way you deploy them. So we didn't share a lot of notes, but we kind of arrived at the same conclusion. And now we're hoping to share some notes with you. I think this is important, and I think as we all kind of get on about this class of computing, it'll be helpful to all of us.
One more question. Yep.
Kevin Flowers, Coca-Cola Enterprises. Can you give us some lessons learned with regard to taking a legacy application and strategic applications and driving them towards a more fundamental SOA architecture?
Yeah, the part of it is so one of the commentary desk people, I can't remember which one, said that the cultural issues were probably some of the hardest, and I completely agree with that. Getting the team to buy into this journey was, again, kind of a story. It was a macro story because everybody felt like they were doing a good job, and they absolutely were doing a good job on their applications. It was the macro picture that looked unsustainable to me, and how all these applications interfaced and worked over time was just so intense. So we had to prove that the service orientation was a smarter way of doing things. And so we took small stuff like currency conversion. We had currency conversion being written all over the company. And so one of our first high-performance services we put out there was currency conversion. And we let people play with it and dabble with it, and it worked fine, and it was supportable, and it was resilient across multiple sites in the data center network, including internationally. And so that was comfortable to them. Then we started working with things like address. We had, believe it or not, a couple hundred applications in the infrastructure that dealt with address, and how to manage address and how to store it and keep it. And so we started spinning up an enterprise address service that made it, much more common and easy to access, addresses. And we used some pretty creative technologies in the data management space that allowed for Europe to have a third address line because they needed it. But you don't even see that in the U.S. We call them stanzas of the data and various stanzas that get added on. And kind of in the iTunes world, that's like how a tune for 99 cents over time became books and television shows and movies and now even software applications. Those are just stanzas of the same service infrastructure and ability to access those services. So I will tell you we have a long ways to go with regard to full adoption. Getting the applications through that modernization process was one way that we really began to win that battle, because once they got into the core environment, then they were able to very effectively access these new services. And when they needed them, it was easier to go tap. It was easier to get a tune for 99 cents than it was to go out and, scan around the world and try and figure out where a safe place to get that song might be.
Looks like we're out of time. Rob Carter, thanks very much.
Great, Rob. Thank you. Awesome. Thank you.